Hi guys, so today we're continuing our conversation about matter. In yesterday's lecture, we heard all about mixtures, and can you remember the two types of mixtures? Homogeneous and heterogeneous, right? And we talked about the idea that milk is a heterogeneous mixture that's been homogenized, and hopefully you guys have had a chance to go through your house and make some homogeneous and some heterogeneous mixtures. Today, we're going to be talking about the other type of matter, which are when we are not a mixture, instead we are a pure substance. So a pure substance is just one thing, and today we're going to pick up the lecture, finishing with mixtures, and then moving on to pure substances. And then at the end of today, we'll put it all together into one big chart that you can use to study how matter is related. So if it's not a mixture, then it is a pure substance. So mixtures can be homogeneous or heterogeneous mixtures, two or more things, evenly mixed or not. But if it's not a mixture, then it's a pure substance. Okay, a pure substance is just one thing. It's a fixed composition, like a glass of pure water. Every part has the same characteristics, no matter where you get them from. Every part has the same composition, no matter the source. It can be written as a formula, like H2O. It could also be written as a formula, so you could have a formula like H2O, or you could have a formula like O2. Okay, these are examples of pure substances. So it can be written as a formula. Every part has the same composition. They can be elements like oxygen or carbon, or they can be compounds like water or carbon dioxide. These are all pure substances. So a pure substance is the same all throughout. So no matter where you buy your water from, now water is a little tricky because there can be dissolved minerals in it. We're really not getting into that. We're talking about water, pure water. If you bought pure water from no matter the source, water is water is water because it is a pure substance. Carbon dioxide is the same. They are made the same because they have a fixed composition, the same characteristics, and the same composition. Every part has the same composition, so it's not even a mixture, okay? It's just one single substance. Sugar is an example of a pure substance. So sugar can be written as the formula C12H22O11. Every bag of sugar that you buy is the same. So if you go to the grocery store and you see 7 different brands of sugar and you brought them all home and you tested them all, they should have the same chemical composition. So what makes the difference in which one you buy? Well, you might have a moral reason, like you prefer, to buy from a place that's fair trade, or you want the sugar to have been treated organically, not treated with pesticides, or you want it harvested in a sustainable way without the sugarcane burning. Whatever you want, but the sugar itself in the bag is the same because it is C12H22O11. No need to spend the money on the name brand here unless there's a bigger reason, like a moral reason, that you would want to buy a particular brand of sugar. And so here we see a difference of the 3 kinds of compounds, the 3 kinds of matter that we have talked about today. So we have one example of a pure substance of water, right? Elements combined in definite proportions, H2O written as a formula. In the middle, you have potassium chromate here, and this potassium chromate is a homogeneous mixture of potassium dichromate dissolved in water. So you can see that it's the same throughout, right? It looks the same throughout, no chunks, no nothing like that. And on the far side, we have cobalt-2 hydroxide. Cobalt-2 hydroxide has this kind of chunky stuff and this purple liquid. What that's telling us is that it is a heterogeneous mixture. It's not the same throughout. The sample varies by layer. There's different phases all described in the same layer. So if we break down pure substances even further, we can describe them as elements or compounds. So first we're going to start with an elemental substance. An elemental substance is made of only one kind of element. So you can have a pure element here like oxygen, or you can have an element like carbon that is combined to make diamond in an orderly fashion, or is a little bit more disorderly arranged and exists as graphite. So both diamond and graphite are made up of only carbon atoms. They're both considered elemental substances. The difference is just how they were treated as they were formed. Diamond, as you may know, is created under immense pressure. And so that diamond, that's why it has such a hardness to it. That diamond was created under immense pressure, where the graphite formed just under less pressure, but of the same materials. Oxygen is also considered an elemental substance. So the trick to the elemental substances is that many of them, elements for sure, you could find on the periodic table. Some you can't, like diamond or graphite. I wouldn't expect you to know off the top of your head that graphite was made of pure carbon. But if I told you that graphite was made of pure carbon, I would expect that you would know that that means it's an elemental substance. So that's kind of the line of what you need to know versus what you don't. Elements are what all of matter is made of. So elements are just different like flavors kind of an atom. And so elements are the building blocks of matter. There are 92 naturally occurring elements. We put them together in this periodic table. This is really just a preview, so it says a whole bunch of stuff underneath, but I'm not going to make you know all of that, except for to say that the elements are put into different groups, 1 through 18 across the top, and different periods or rows, 1 through 7. And what that does is it allows us to look up a particular element. So we would say iodine is in group 17, period 5. And that would allow you to identify where you could find iodine on the periodic table. So it gives you kind of like a grid pattern that you can use. And really that's all you're going to need to know about the elements just yet. We will do much more with them, but a little later on when we get to chapter 5. Pure substances, as we mentioned, can also be compounds. So they can be elemental substances, they can be elements, they can be compounds. A compound is made of 2 or more elements, but they're chemically bonded together. They're not mixed together. This is a chemical change. So this is not hydrogen and oxygen next to each other. This is water. They have bonded together. They have made a compound. So elements and compounds are considered to be pure substances. Medications are pure substances, like we talked about with Advil. Our NaCl, our sodium chloride, our table salt is a pure substance. That's also a compound. They're one kind of matter. They're one substance. They're not mixed. It's not 2 or more substances mixed. That's a mixture. They're one substance, but they're chemically bonded. So they consist of more than one atom or element. So this is our big summary. And so what we started, right, with saying that matter, it can be described as either being a mixture or a pure substance. If matter is a mixture, the mixture can either be homogeneous, which means the same throughout, or it can be heterogeneous, which of course means uneven. And in the slide, in the picture, it gives you a whole bunch of examples of homogeneous and heterogeneous, or homogeneous and heterogeneous mixtures. Our pure substance can either be a compound or it can be an element or elemental substance. The difference being that a compound is made of 2 or more types of elements, where an elemental substance is made of just a single type of element. So things like oxygen, carbon, nitrogen, and some things that don't have names on the periodic table, like diamond and graphite, can also be considered elemental substances. But compounds always have more than one type of element. So carbon and oxygen as carbon monoxide or carbon dioxide, those are examples of things that are compounds. So this kind of finishes our chapter on our talk of matter and all of the different ways that we can describe it.